So this video is going to cover the density lab through Argos. Just a thing to some things to remember. You want to make sure that you are taking notes. Uh, what you see on all of these Argos labs, there's 10 of them, is that it's information that is free game for the exam. So make sure you're taking notes, writing down formulas, understanding your calculations, keywords, intensive, extensive properties as we see here. So, again, there's some of the things we do want to know as well. So for this, remember that 1 milliliter is equal to 1 cubic centimeter. Right? Milliliters is metric, and centimeters would be considered as I units, but both are units of volume. And then there's three. You should already know them, but I did place in here for you the formula for how to get the volume of a cube, which is length times length, or just length cubed, right? Since it is a cube, not a rectangle, all the lengths are the same size. Volume of a sphere, 4 pi, radius cubed. And when you're doing these calculations, use pi. Don't use 3.14. Use the pi symbol on your calculators. And just as a reminder from what you learned in unit, well, one, density is equal to mass over volume. There are a couple ways to rearrange it. If we wanted to calculate volume, that's mass over the density. And if we wanted to calculate mass, that would be volume times the density. And here's down here, you'll see volume of a cylinder, pi times the height times its radius squared. And we're going to be using this one, and I've rearranged it here, but we'll talk about that in a few. So there are a few things to weigh here. This is our balance that we learned in the lab techniques and how to open, close it, how to tear that out, make sure it's zeroed out. Now, when you're going through, so I'm not going to go screen by screen here. Uh, Page 5 is really important. Make sure that you use the click here button, right? Click here because you are going to have to refer to this page several times. Then you don't want to keep hitting the back button. It's just easier to open this tab up and then you have all your information regarding the densities of plastics, metals, metal alloys that we have there. So you can just always keep that open. Now to get the mass of the cube. So this is I don't know why this is, but this just does happen. The students panic and they know that it's not working, it's not recording. I'm gonna place this in here. I'm gonna close this up. I already did tear it out, so this is the mass of it. Generally, I like to click in here and I like to see that little cursor, right? Um, I'll hit record, and then sometimes you do have to hit record again, and there it is, and the mass is now recorded. If for whatever reason this is just not recording, you can restart this yourself. So you just hit this button here, restart lesson, and then you restart this in here. Now, there's unlimited attempts up to the due date. Okay, it'll record your highest score that you want. If you're trying to get 100, you can do it again because you missed a question, missed a calculation. Restart the lesson. You can start it all over. If it's not restarting for you, then email me and then I can restart on my end. We'll just move to the next page, right? You get some, if it's correct here, it'll say good job, right? And we can move on. And notice how this value is in here now, okay? It didn't erase, is that we would have to physically, oh, let's zero that out. And if I want to record this value again, this is just out of habit. I just click in here, might have to hit, there it is. And then now that value is recorded. Now, there is some other key information. Don't make sure you're reading through this because there's other key information here that we are going to need later on. Enter this value in your notebook. And again, I did remind you earlier to write this stuff down. It is on your data sheet here. Here's the one for the cube. You're not going to see the one on the cylinder until you hit the next button. But beyond this, make sure you are reading all this because it does state this. The cylinder is 3 centimeters long. Why would we need that? Well, we're going to need that because that's the height of this, right? We're going to need it later when we calculate the volume of a cylinder, okay? It was on the previous page. I will go back to that. Mass of the cube. The plastic cube is 3.2 centimeters long. Why do we need that? Because we need the volume of the cube, right? So make sure that you are um, writing this information down, looking for, information that might be relevant. You won't have this here. This is just for the instructor here. I'm gonna just hop a couple pages. There are some calculations for you to make here, right? Use the cube length, which they provided, 3.23. You can then do this calculation over here, right? And figure out what that volume is. And how many significant figures should we use? Well, if there was three significant figures for the length, it would make sense that we would have three significant figures, which again, we learned in Unit 1. And to calculate density, you have your density formula here. Mass over the volume is your density. And this is where you're going to need to go. So it's actually to compare densities, and you're going to actually figure out by calculating the density what the which plastic that we were working with there. Right. So again, and then you're going to do something similar for the volume here. Now, as far as the radius here, so it's not calculated for the cylinder. We're using the mass of aluminum, and we're using the density of aluminum to calculate its volume, right? So this is where we're going to be using here, right? Volume is equal to mass divided by density. We get the mass from here, the density from here. We can calculate its volume. And volume of a cylinder, right? If we know what the volume is and we know what the height is, we can calculate what that radius is. We just rearrange it, and to calculate that, after it's been rearranged, to calculate the radius of it, we're going to be doing the volume of it, which has been calculated up here, divided by pi times the height of it, or how long it is. I'm sorry, how they have how long it is. But the height, and that's going to equal the radius. And then moving on, there's some other calculations to make here. Here, some students get a little stuck here. It says mercury is a liquid at room temperature. Its density is provided on the table on page 5. Give the symbol of an element listed on the same page that'll float in mercury, right? The symbol. Don't put these words in. Don't put in copper, put in Cu. Don't put in lead, put in Pb, Au, Hg, Ag, Al, right? That's what it's looking for here. Here we're putting in symbols. And that should finish off the density lab.